Hi everyone, today we are going to learn about the Newton's laws of motion. We know that there are three Newton's laws of motion, popularly known as Newton's first law of motion, Newton's second law of motion and Newton's third law of motion. Let us see about the Newton's first law of motion. This Newton's first law of motion is also called as law of inertia. Why is it called as law of inertia? Because this first law of motion is defined on a physical quantity called as inertia. What is inertia first of all? Generally, the ability of an object to be in state of rest or motion to oppose such kind of change in the state is called as inertia. That means the capacity or the property of an object to oppose the change either in the state of rest or motion is called as inertia. Suppose an object is moving, it tends to move continuously and it doesn't stop unless it is acted upon by an external force. Suppose if we have another object which is at rest, it doesn't move, and that property is of an object can be called as inertia. Inertia is a beautiful concept and which depends upon the mass. More the mass, more is the inertia. And there are three kinds of inertia. Number one, it is inertia of rest. Second one, this is inertia of motion and inertia of direction. Suppose, what is inertia of rest? A person who is sitting in a bus which is at rest, if it starts suddenly, he feels a jerk in the backward direction, and that property is called as inertia of rest. And we can take several examples. Suppose a person who is sitting behind a pillion ride, if we can consider, suddenly if the person who is riding the bike, if he starts with a huge speed, he may fall back. That incidence you can see in your daily life. That property of an object is called as inertia of rest. Now let us come to the second one, that is inertia of motion. When an object is in motion, suppose a person moving in a bus which is under motion, if the brakes are applied and suddenly if it gets retarded, he falls forward. And that property is called as inertia of motion. We can come across so many examples of inertia of motion in our daily life. The fan which rotates, when it is switched off, immediately the fan doesn't stop because of inertia of motion. And even we can take another example, the person who gets down from the moving bus, he stops after moving to a certain distance. That is because of inertia of motion. And the third one we want to see is that inertia of direction. Inertia of direction in the sense to oppose the change in the direction of an object. If suppose a person who is sitting in a car, if the driver takes a turn towards the left side, then the person who is sitting falls towards the right side. If the driver takes a turn towards the right side, the person falls towards the left side. This comes under the inertia of direction. That means if he is turning towards the left side, he is opposing to move towards the left and hence he falls towards the right side. That property is called as inertia of direction. Now, this inertia is the only quantity which depends upon the mass, as I said once. Let us see a small example that we have two objects of masses m1 which is 40 kg mass and m2 which is having a mass of 60 kg. Suppose if someone asks us which has got the more inertia, obviously the object which has got the great mass, the highest mass, that has got the more inertia. Let us take a simple jovial example that a little child is running and a sumo is also running along with him in a running race. It becomes difficult for us to stop sumo compared to the little child. That means that sumo is having more inertia of motion because he is heavy and hectic. But what about the little child? We can stop him very easily, and even we can stop him very easily, and he comes to rest as very small force is applied. But to stop that hectic person, we may require some machines too, if I am not wrong. Okay, this is called as inertia, and inertia is directly proportional to the mass of an object. Now let us define this Newton's first law of motion. Newton's first law of motion states that every object continues to be either in the state of rest or uniform motion unless it is acted upon by an external force. That means when no net force is acting on an object, the object will be either at rest or in uniform motion. This is the important thing. That means when F net, the net force acting on an object is 0, the object is either at rest or uniform.